Well, this is the Grizzly G1006 that I'm going to be converting to CNC. It's really not worthy of converting to CNC, but I'm going to anyway, which is why I'm calling it CNC turd polishing. It's pretty much just a mill drill combination. It's a benchtop mounted. It's got about 22 inches in the X, about 7 inches in the Y, and about 5.5 in the Z, or a little over 5 in the Z. I just have it currently sitting on a rather somewhat flimsy Kennedy tool cabinet. I may anchor it to the floor a little later if it starts rocking a bit when it's moving, but I probably won't be driving it all that fast. It's got a 1.5 horsepower, or actually got a 2 horsepower single phase motor in the back. I'm going to be converting that to a 1.5 horsepower with a VFD under computer control. And it's got the old belt drive system up there, the 2-stage reduction system. I'm going to be converting that into a single stage. So far I've added the this segmented belt. Runs a little smoother with that on there, so I'll be keeping that. It's adjustable, you can make it whatever you want. So I'll be running it from the front to the very back pulley, and I'll be getting rid of this middle pulley. More on that later. Here's one reason this is not a good candidate to convert. This round column, it means that anytime you adjust the Z beyond the rather limited 5-inch quill travel, you'll lose the X and Y. It'll rotate around the round column, and then you'll have to re-zero the X, Y, and Z. So I'll be getting rid of this plastic belt enclosure as well. So quite a bit of it's going to change. There'll be a new front panel. All this goes away. It'll just have a cycle start and stop. The main power will be down on the electrical control panel. I've actually designed quite a bit of it already. But the big news is the enclosure. I've made a just an all-white vinyl. It's an 18-ounce per square yard vinyl, rather heavy vinyl. It's like an industrial shower curtain, really. And all I've done is just tacked it up to a framework up on the ceiling, and it all just hangs under its own weight. But that'll keep the chips in place. This is what I'm doing for an enclosure. And it'll also hide a lot of my messy basement so I can make videos and not be too ashamed. But anyway, the enclosure is pretty simple. Just went on eBay, found a PVC vinyl tarp. It's a heavy reinforced, just a fabric material. And hung it. The wrinkles still haven't fallen out of it yet. I just finished that today. And it goes down to within an inch or so of the floor. So the chips just fall on the floor now and can be vacuumed up rather easily. So that's a major advantage for a basement shop where I was having to clean up chips flung all over the basement. That's particularly a problem with the Tormach Superfly. It's sort of like a fly cutter, but it's also kind of like a one insert shell mill. You can get busy and pull a lot of material off with it, but it flings those little chips all over the place. So now they'll all be a lot easier to clean up. So a quick synopsis of what I'm going to be doing. The first axis I'm going to do is the X-axis. This wheel comes off, and I'll mount a plate here. The plate will stick back here, and then the motor will stick out. The big X stepper motor will stick out here, and there'll be a 1-to-1 belt drive system to couple the rotational motion into the lead screw here. I was originally thinking about replacing the lead screw, and I may do that with a ball screw. But the first thing I'm going to try is putting a Delrin nut on there. It's a trick where you cut a nut and bore a hole through it that's about one thread depth on one side, smaller, and then heat it up, cut it in half, and then clamp both halves on their clamshell, and then heat it up and press it in a vise, and it forms the Delrin to Acme lead screw. Makes a 0 backlash. So I'm going to try that and see how that works. That may be just fine for this no fastener I plan on going. The friction's a little higher than you'd have with ball screws, but that actually might be a good thing here because there's not a lot of mass here. Mass is what makes rigidity most of the time in machine tools, so that friction will keep that lightweight table from sliding back and forth when it's cutting under a rough cut. So I'll try that first on the X, and if it works well, I'll do the Y that way. Same thing here. I'll have a plate mounted here. The motor will be down on this side, and then there will be a belt driven to wheel here. And I actually have all the hardware to do the X and Y conversions, since I haven't done them yet. And then the Z, this hand wheel comes off. I've already taken the spider off. There used to be a 3-arm spider for using as a drill press. I took that off originally when I got it, probably 10 or 12 years ago. I've been using it sort of like a cheap milling machine since then. But the this little cheap plastic handle comes off, and there'll be installing a timing pulley here, short timing belt. There will be a metal piece attached up here, and so the flat plate of aluminum will come out, and I'll have a motor mounted somewhere up in here heading back in this direction that'll be driving this. It's 1/10 of an inch of quill travel for every revolution. So there's the X, Y, and Z, and I actually have a 4th axis, and it'll be made so it can mount on and off rather quickly. I've got soft jaws in here now. What I'll probably do is just drop the 4th axis into the soft jaws, wire it up, and when I don't use it, just store it under the table, and that way I can have a 4th axis when I need it and have it out of the way when I don't need it. So I've already designed all the electronics for this, so I'll be uploading the video soon with the electronic control panel build. It's at the time of making this video, I've already built the panel. I'm just going to wire it either tonight or tomorrow, and then I'll upload a sped up version of that, like a 60-to-1 time compression of me building and wiring the panel. And I'll have a whole bunch of stuff for anyone who wants to follow along in this project and maybe wants to do some of this themselves. I'll have schematics and, nothing pretty, but the information will be there. Sources, how much stuff costs, where to buy it, that sort of thing. So if you're doing it yourself, you should be able to follow along pretty well. And if you got any questions, just leave them down in the comment section, and I'll be pretty good about answering it. So hope you all enjoy this project. Follow along with me as I convert the milling machine to CNC, turd polishing CNC. I'll be using Linux CNC for this. I've used it for a couple other machines and really like it. So that's my crappy little import mill, soon to be a crappy little CNC mill, and my brand new enclosure. I'll have doors on the front of my enclosure someday soon. For right now, the front's open, but I'll have sliding doors, pretty much a rip-off of the way Tormach did their enclosure doors. Kind of like that, fairly cheap, and seems to be a good way of doing it. So I'll have, throughout this series, I will just do one thing at a time. So you'll see the electric control panel next, and then probably the X motion. So you'll see the mounts and all that, and then the Y, and then maybe the Z. Power drawbar. I'm planning on having a power drawbar. I've already bought the materials for that, and have all the pneumatics and stuff to operate it. So I'll be integrating that, and that'll be a video of its own. The 4th axis will probably be a video of its own. So I'll have several videos going here, and each one just per topic. So hope this was somewhat useful and whet your appetite, and maybe have some questions down below, and I'll answer them, and we'll get this thing going. See you next time.